Hello everyone, this is Shatarupa and today we are going to solve some important pseudocode question which has a chance or a similar kind of a question can be asked in some online tests, right, for placement. So before I go to the first question, I'll be giving you 30 seconds. You can just solve that question and then we'll solve it together, okay? And if need be, you can even pause the video. So let's go to the first question. This is the first question and your 30 seconds starts now. So if we look into this question, it's basically a pseudocode, right? So where there are certain integers that are given. So it says a is equal to 4, b is equal to 5 and c is equal to 3. Now we'll do it stepwise. B is equal to 3 plus c. So 3, what is the value of c? It's 3 again, so 6. So now your b value will change from 5 to 6. Then it says a is equal to b of AND a. Now this is a bitwise operator, right? So this is a bitwise operator. So now what is the value of b? It is 6. 6 bitwise operator, that is and what is the value of a? A is still 4. So that means we have to find the binary. Now binary of 6 is 110 and binary of 4 is 100. So now if we perform the AND operation says whenever both are true, the output is true. So for 0 0 it will be 0, for 1 0 it will be 0, for 1 1 it will be 1, right? So again, what is this value? This is 4. So what is your a value? A value remains unchanged, that is 4. Okay. Now c is equal to c plus b. Now what is the value of c? C is 3 and what is the value of b? B is 6. So the value of c changes to 9 and what is the value of a? A is equal to a plus b. So a is already 4 and b is 6. So the value will change to 10, right? So finally it says print a plus b plus c. So value of a is 10 plus value of b is 6 plus value of c, that is 9. So now if I add this is 10 plus 15, the answer is 25. So 25 will be printed as your output, right? I hope this is very clear. So remember, you need to know the binary form of each and every number, or you need to know how to find out the binary of each and every number, and then you need to know what in bitwise AND does, what in bitwise OR does, and what XOR does. These are the three main things, that is AND, OR and XOR. These are the three main important bitwise operator that often is asked. Okay, so for this the answer is 25. Moving ahead to the next question. Please read it carefully and your 30 seconds starts now. Okay, so here the first line says that there are two values given. One is the value for k and other is the value for j. Now if you carefully observe this code, the pseudo code, it is a code of recursion, right? So now when we draw a recursion tree, there are generally two parts. One is the right part and other is the left part. Okay, so for here if we are solving, k is equal to 3 and j is equal to 4. So first let's do it for the left side, then we'll go for the right side, right? So it says if k is equal to 1, it's not correct, right? So it will not go to the if part, it will go to the else part. Now else part says that you need to return function k minus 1 and j minus 1. So what will be the value of k over here? The value of k will be 2 and the value of j will be 3, right? K minus 1 and j minus 1. Again, the value of k is 2. It is not equal to 1. So it will again move on to the else part and it will solve again for k minus 1 and j minus 1. Now the k value will change to 1 and j value will change to 2. Now it will get satisfied on the if condition that k is equal to 1. So it will return 1. So what will it return to the previous function? It will return 1. Now, while it goes back over here, only one part of this recursion is solved. The other part is still pending. Now, what does it has to say? It says k minus 2 and j plus 3. So, k value over here is what? It is 2. So, k minus 2. 2 minus 2, k value will become 0. And j plus 3. Here the j value is 3. So, 3 plus 3, j value will change to 6. Now, you see in the if condition, okay, there is a mistake. Just change the or part, make it or k equals 0. Okay, just change this question, k equals 0. So this one, again when k becomes 0, this part will be updated. It will again return 1 over here. Okay, so now if you check, what does this function say? This says return func k minus 1 j minus 1 plus func of k minus 2 j plus 3. So this 1 and 1 will be added. So what will this function return over here? It will return 1 plus 1, that is 2. Right? Now we are here on this top node and we have solved it for the left side. Now let's solve it for the right side. So for right side, what will it solve? It will solve k minus 2 and j plus 3. Right? So k minus 2, how much will it be? 3 minus 2 will be 1 and j plus 3 it will be 7. Now again k is equal to 1. So what will it return back? It will return back 1. So what will be your final answer of this node? It will be 2 from the left side and 1 from the right side. So 2 plus 1, the answer will be 3. Okay, so whenever it is a recursion, remember you have to draw a tree this kind. First solve for the left side, then solve for the right side. Okay, clear? For this the answer is 3. Okay, this is what you're getting. You're returning 1 from here, you're returning 1 from here. So 1 plus 1 will be returned as 2. Now entire left side is solved. So you don't have to focus here. Now it will focus on the right side. Okay, so for right side it will be k minus 2 and j plus 3. So again k will become equal to 1, so it will return 1. One correction that you need to make in the question is in this part. Okay, the if condition will be something like this: k is equals 1 or k equals 0. Just make this correction. It's a printing typing error, so this has to be 0 and not 1. Okay, because if it's 1, then both the conditions are same. There is no difference in the condition. Okay, let's move ahead to the next question. So this is the third question, a very simple pseudocode. Try solving it. Your 30 seconds starts now. Okay, so now if you observe carefully, this question has two for loop, first one and second one, and condition of both the for loop is same. So let's first evaluate the condition. What does it say? Is that for each z from 0 to 3 minus 2. Now what is 3 minus 2? 3 minus 2 is 1. That means z will run from 0 to 1. So how many times will the loop run? The loop will run 2 times. Why? Because if I say you to count from 1 to 10, you will count starting from 1, you will end at 10, right? So both the numbers will be inclusive. Thereby, if it is from 0 to 1, both the numbers are inclusive. Thereby, the loop will run 2 times. Okay, clear? So, both of these loop will run 2 times. Now, if you observe this condition, if 1, we know that any number, any non-zero number is always true, right? So if 1, that means this loop will run always, this part will always be executed, whether this part is executed or not, this part will always be executed, right? Because if of 1 is always true, okay, because 1 is a non-zero number. Alright, so now just let's have a look on this question, okay. So x is equal to minus 3 and y is equal to 0. So now if 0 minus 2 less than 2, so minus 2 is always less than 2, this is true, so it will enter the loop, okay. Now once it enters the loop, how many times will it run? It will run 1 for the 0th time, 1 for the 1 time, right? So now let's execute for the 0th time. So x is equal to x plus y minus 3. So what is the value of x? It is minus 3 plus of, what is the value of y? It is 0 minus 3. So that means it is minus 3 and minus 3, which is minus 6. Now it is going to execute again for 1 time, the second iteration. So x is value is now minus 6. So minus 6 plus of, what's the value of y? Y is still 0, minus 3. So what will be the answer? It will be minus 9, right? Now moving down to the next if condition. So this is always true. So now when it runs for the 0th iteration, x is equal to x plus y plus 5, right? So minus 9 plus 0 plus 5. So it will be minus 4. Now when it runs for the first iteration, x value will change to minus 4. So it will become minus 4 plus 0 plus 5. So the answer will be 1. Now this is the end of if, okay. Now it says that print x plus y. So what is the value of x? We just derived it over here. X is 1 plus y. Y has never changed. So whatever y was there in the beginning, that is what it will remain. So that is 0. So 1 plus 0 is 1. So your output will be printed as 1. Okay. So make sure whenever there is a loop condition which says from a certain number to a number n, both the numbers are inclusive, okay. So if it's written in word, if it's written in form of an operator that is less than n, then that is fine. If it's stating something like this, for I is equal to 0, I less than n, I plus plus, then n is not inclusive. But if it is written in form of word, like here, for each I from 0 to n, then this implies that n will be inclusive. It might be written in form of n, or it might be written even in form of like this. That means this number is inclusive, okay. So that means the loop will run from 0 to n times. It will run for that many times, okay. But in case if you are not considering this n, like suppose over here, if we did not consider that the loop would have been running for 2 times, then we would have got an answer as minus 1. And there is a 99% probability, or I would say 100% probability, that minus 1 would have been an option. But what we got as an answer was 1 because we ran the loop twice. But if we don't run the loop twice, we'll get the answer as minus 1. And most of us will tick minus 1 and we'll come back, right? So that will give the wrong answer. So always be very particular on what the terminology is used in the question. Okay, now moving ahead to the fourth question. It's a very simple question but tricky. Give it a try. Your 30 seconds starts now. Okay, Now if we look into the question, A value is 11, B value is 4 and C value is 3. Now it says B not equal to not of A. Okay, this line might look a little confusing. Why? What is this? Now, if it's written within a condition, if it is a condition, right? B not equal to 10. So what does this imply? This is just in comparison. It's not an assignment operator, it is in comparison. So here also it is a comparison. So it doesn't matter what the value is over here because it is always not equal to. Right? So B value at the end will remain unchanged, that is whatever is there in the beginning. So you don't have to really bother about this statement, that is just given to confuse you. Okay, understand that not equal to is a comparison operator and not an assignment operator. Okay, so it doesn't matter what it's being compared to because it is always not equal to. Okay, so it will either return true or false. So you don't have to worry about that because B value will always remain unchanged. The value of B will never change. It's in comparison. Now, where will you catch this comparison? Is there some condition? Is there something written to satisfy this or to catch this comparison output? No. There is nothing there. If this had been put inside a if condition, then okay, fine, I would have considered it. But there is no place over here where I'm catching whether this condition is true or false. So just ignore and keep the value of B as it is, whatever it is. Okay. So B value remains unchanged. Now C is equal to not of not A. Now this might be little confusing. This you can break it down as C is equal to not of not A. Now, if I further break this, I can write something like this. So now, what is the value of A? It's 11, right? Just previously in the first question, we spoke about that every non-zero number is true. So 11 is a non-zero number. So this will return true, right? Now, not of true is false, right? Not of true is false. It's not true. Then what is it? It is false. Now, not of false, it is not false. Then what is it? It is true. So what value will true return? True will return 1. So what will be assigned to C? C will be equal to 1. Okay. So what will be your printf doing? Printf is printing B and C. So B value, as mentioned, it will stay unchanged. And what is the value of C? It's 1. So what will your output be? 4 and 1. Clear? It's a very easy question. Just understand how trickily they have used the not operator. Break it down. Understand that not equal to is a comparison and not an assignment operator. Then you're done with the question, right? Moving ahead to the fifth question. Your 30 seconds starts now. Okay, what is a B tree? B tree is nothing but a binary tree. Now it says for a B tree of order 6 to be a multi-way search tree, each non-root node has at least how many non-empty children, right? There is a very simple formula. B tree of order M, okay, has at most M non-empty children and at least M by 2 non-empty children. So this is the formula. Okay, for at most it is straightway that number and for least it is half that number. Okay, so if we read the question, it is asking us for at least. So here what is the order? Order is 6. So m is equal to 6. So for at least it is m by 2. So 6 by 2, the answer will be 3. Had it been at most, then it is directly equal to the order of the tree. So your answer would have been 6. So since the answer is at least, thereby the question is at least, thereby our answer will be 3. That is in option number A. Right? It's very simple like this. So always understand there are certain tricks, there are certain formulas in which you can actually find out the least and the most. You need to remember them. Okay? Now, moving ahead to the 6th question. This is a postfix expression. You need to find out, you need to actually evaluate it. Okay? So evaluate and find out the answer. Okay, so for any postfix expression, we are going to consider a stack. Remember, whenever it is an operand means any number or any alphabet. Okay, if that is an operand, then you push that operand, that number or that alphabet into the stack. If it is an operator, then pop two elements from the stack. Clear? So let's consider this simple stack. Okay, so here 1 is an operand, so push it in. Then 2 is also an operand, push it in. Now plus is an operator, right? Since plus is an operator, pop it. Pop 2, then write plus, then pop 1. So both of them are popped out. So what is the value? 3. Now this resultant will again go back into the stack. Okay, so place here 3. Now 3 has been placed over here. Okay, so again what do you have here? You have this 3. So again push 3 into the stack. Okay, so first we put in 1, then 2, then we got a plus sign, right? So now when this is a plus sign, we are going to pop how many elements? We are going to pop 2 elements. So first pop 2, then pop 1. So what is the answer? Answer is 3. Now where will this 3 go? This will go back into the stack. Okay, so we'll write here 3. Now if you notice, there is again one more 3 in the question. This is the answer, but in the question there is one more 3. So again push it back. Again what we have? We have multiplication. So pop out this 3. This 2, 3 will be popped out. So answer will be 9. Now what will go into the stack? 9 will go into the stack. Now what do you have? You have 4. Push it in. Then again 2. Push it in. Right? Now it's minus. Okay. So since it's a minus, what will come over here? It will be 2, then 4. Okay. So 2 minus 4 will be 2. These two are popped out. Okay. Now again this 2 will go inside. Okay. Now what you have? You have 3. Push it in. Then again what you have? You have 1. Okay. Now there is a plus sign. Yes. So this plus sign, you have to pop 2 elements. These 2 will be popped out. So 1 plus 3 is 4. Now push in 4. Okay, then there is multiplication. So pop these 2 out. What is it? It is 4 and 2. That is 8. Right? Now again push back 8. Okay. So what do you have left with? You are left with minus. So 8 and 9. These 2 will be popped out. What will be your answer? Your answer will be 1. Okay. So this is how you actually do it. You always have to push the operand, that is a number or an alphabet, and pop out 2 elements whenever you come across an operator. Even the resultant value will be pushed back into the stack. Okay. So this will be the answer. So your answer is in option number B. That is 1. Clear? Great. Moving ahead with the 7th question. This is again a simple kind of a question and your 30 seconds starts now. Give it a try. Okay. So it's saying if you're using a bubble sort to sort the given number in ascending order, then find out the minimum number of swaps required, right? So this is our initial array or the list of numbers that we have, and we need to sort it in ascending order. Now what does ascending order bubble sort do? It simply checks whether this number is greater than this or not. If it is, then swap it. So it is greater than this, so the first swap will look something like this. Now it will again check this with this, so it will become 7, then 5, then 10, then 8, then 9, right? Then again it will check with this and this. It will again swap. It will be something like this, and again it will check like this, right? Now if you notice that the highest element is at the last position, okay, or the largest element is in the last position, so this one complete thing is known as pass. So this will be known as one pass or pass one. Okay, now again it will compare with the start. So is this greater? Yes it is. So again it will swap, right? Now I think the entire list of number is sorted. Okay, so how many swaps did it take? 1, 2, 3, 4, 5, right? 5 swaps to get back to the actual thing. Oh sorry, it will be 6 swaps. Here 1, this was 2, 3, 4, 5 and 6. Okay, so your answer will be in option B, that is 6. Okay, it will take total 6 iterations. Okay, great. Moving ahead to question number 8. This is again a min heap. So before you start solving, I'll just tell you, arrange the given array in a min heap first and then try inserting it. Okay, I'll give you 30 seconds, give it a try. Okay, so what does a min heap says? Min heap says that the root node or the parent node should be minimum than the child node, right? So if we consider this given array, then it will be something like this, right? Now 25 is to be inserted. So where will it be inserted? It will be inserted somewhere over here, right? Now it will compare whether the parent of 25 is greater than 25 or not. If it is, then what will happen? It will swap, right? So it will see yes, the parent of 25 is greater, that is 30. So this is not the min heap. So what will happen? Swapping will take place. So how will be the values looking like then? It will look like this. 15. Here it will be 25. 40, 50, this will be 130, right? This is how it will look. And how do we write a min heap? Like this way. Okay, so it will be first 10, then 15, then 25, then 40, then 50, then 100, then 30. Okay, wherever this option is, that is the answer. I assume the option is in answer is in option number B. Right? So whenever you are solving for a min heap, make sure that the parent node is smaller than the child node. But if the parent node is not smaller than the child node, then make a swap them. Okay, just like we swapped 30 and 25. Okay, now if you see that every parent node is smaller than the respective child node, right? Yes or no? It is, right? So thereby make sure that you write it something like this. And how do you finally find out what will be the order or what will be the set of the output? Make sure it's always from left to right. Okay, so first 10, then 15, 25, then 40, 50, 100, 30. So that is an option number B. So option number B is your answer. Moving ahead to question number 9. Read the question very carefully. This is just the opposite. It is max heap. I give you 30 seconds. Find out the proper answer. Okay. So now there are 3 points that are given, right? 1, 2 and 3. You have to find out from which of the following 1, 2 or 3, which of them is not a representation of max heap. Is not. Very important. Do not find out which is the representation, which is not the representation. Now we have to individually check for all the 3 options. Now like in mean heap we spoke about that the parent node is smaller than the respective child node. In max heap it's just the opposite, that the parent node is greater than the respective child node. Right? Now let's do it. It is 31. Okay, then 27, 23, 17, 13 and 11. Right? So this is the parent node. So the child node is smaller than the parent node is greater. Okay. Now again over here, the child node is smaller, parent node is greater. Okay, the child node is smaller, the parent node is greater. Then this one, that option 1 is a max heap. Now let's move on to option 2. Says 10, then 5, then 3, then 2 and 4. So 10, it is greater than 5 and 3, correct? 2 and 4, it is greater than, it is smaller than 5. Right? So that means this is also a max heap, because everywhere the parent node is greater than the child node. Right? Always remember, we write the heap from left to right. Always try filling both the child moving before you move on to the next heap, next side. Okay. Now, so 1 and 2, they both are max heap. Now let's find out for the third one. So 12, then 15, then 17, then 18 and 19. So here only I can see that 18, 19 is greater than 15. But in max heap, the parent node has to be greater, right? So this is not in max heap. Okay. So which of the following array representation is not in max heap? The answer is option B. Only 3 is not in max heap. Otherwise 1 and 2, both of them are max heap, where each parent node is greater than their respective child node, right? In other way, when you just found out that 1 and 2, both of them are max heap, you did not have to solve for option number 3. Blindly you can mark that option number 3 is the only one which is not in max heap, because 1 and 2, they both already satisfy the condition of max heap. So you don't have to even solve for option 3. Okay, because there are no other option 1, 2 and 3. So when 1 and 2 both are max heap, 1 has to be correct. So thereby it is option number 3. But yeah, if here there would have been an option that none of the above, then of course you have to check for this as well. But since there is no such option, 1 has to be the answer. Thereby once I know that 1 and 2 are max heap, I don't have to check for the third one. Third one for sure will not be in max heap. So my answer is option number B. Only 3 is not an array representation of max heap. Why? Because the child node is greater than their parent node, which should not be. Right? Moving on to the 10th question. Give it a try. It's again a pseudo code and your 30 seconds starts now. Okay, so now let's just have a look at it. It says A is equal to 7, B is equal to 7 and C is equal to 4. Okay, now again from 4 to 7, that means both the numbers are inclusive. How many times the iteration will happen? 1 for 4. sorry, once it will happen for 4, then for 5, then for 6, and then for 7, right? And there are certain values that we need to find out. What are the values being updated? B, B and A. Again B, B and A. So we have to find out the value of B, B and A in each case, right? So the initial value is already given over there. A is 7, B is 7, C is 4. So 2 plus A. So 2 plus 7, that is 9, right? So now the B value has been updated. So 9 plus 11 plus 4. It will be 9 plus 11 plus 4. So that will be 9 plus 15, right? So it will be 9 plus 15. So wait, I'll just write it down. 9 plus 50, right? So now we have to solve all of them in a similar way for each and every iteration. So this value will be 24. Now for A it will be how much? It will be 4 plus 8 plus A. Now 4 plus 8 is 12 plus 7, right? So it will be what? It will be 12 plus 7, right? So 12 plus 7, the answer will be 19. So here the value of B is 9, 24 and A value is 19, right? Like this way, for how many iterations we have to solve? We have to solve for 5, 6 and 7 as well. So if you just check, then for 5 it will be, when C is equal to 5 it will be 21, 37 and it will be 31. This one will be 33, it will be 50, it will be 43. Okay, here the B value will be 45, 63 and 55. So you can solve it on your own and you can get to know. So now all the iterations are complete till 7. So at the end of completing 7, here C is equal to 7, C is equal to 6, C is equal to 5 and C is equal to 4. Now why is it so? Because the loop is for C, right? For each C from 4 to 7. So now here the loop is complete and this is the final value of individual thing, right? So now it says A is equal to 4 plus A. What is the value of A? It is 55. So 4 plus 55, it will be 59. And then it says print A plus B, right? So now it will print how much? 59, that is the value of A, plus it will print the value of B, that is 63. So it is 122. Your answer is in option number A. Okay, so for each iteration you have to solve like this. Okay, always remember, once this iteration is done, from iteration where C is equal to 5, it will take the updated value. How did this become 21? This was A plus 2, right? So what is the final value of A? Value of A is 19. So 19 plus 2 is 21, right? What was the final value of B? Final value of B was 24, right? So 24, and what has to be done over here? B plus 11 plus C. So it has to be 24 plus 11 plus 5. So that is 37, right? What was the value of A? Value of A was 19. So it was 4 plus 8 plus A. So 12 plus 19, 31. So like this way you have to solve for all other remaining iterations, right? It will take a little time, but if you are really good in addition and calculation, it will be done quickly. So your answer is in option number A, right? With this, we come to the end of this session. I hope this session was helpful to you. So I'll see you guys next time with some other questions, which will be again helpful, which will be a little more in depth with data structure or some other topic, right, which is important from online placement point of view. And if you want such more interesting questions, don't forget to subscribe to Campusmonk. Okay, we keep uploading videos on that, and we do have our app as well. So if you are interested in studying with live classes, you can of course enroll in our app courses. Thank you.